Time travel has always fascinated us. Imagine stepping into a machine and zipping back to witness the signing of the Declaration of Independence, or fast forwarding to see how humanity tackles climate change. Theoretical physicists like Kip Thorne suggest that wormholes could allow for time travel, but the paradoxes, like meeting your past self, raise eyebrows. Some argue that time is just a human construct, while others believe it's a dimension we can navigate. Whether it's through science fiction or scientific theory, the allure of time travel challenges our understanding of reality and keeps our imaginations racing. So, is it real? Maybe not yet, but the possibilities are endless. Time travel into the future? It's not just science fiction. Thanks to Einstein's theory of relativity, time isn't a constant. It bends and stretches based on speed and gravity. This phenomenon, known as time dilation, has been proven with experiments involving high-speed jets and atomic clocks. For instance, astronauts on the International Space Station age just a tiny bit slower than those of us on Earth. Why? Their incredible speed and the weaker gravitational pull up there create a real-life time warp. So, while we can't hop into a DeLorean and visit the past, we're already traveling into the future, just a fraction of a second at a time.
Traveling into the past sounds like a dream, but science hits a wall. One fascinating idea comes from physicist Kip Thorne, who suggests wormholes, these hypothetical shortcuts through space-time. Imagine one end of a wormhole zooming near light speed and then returning. Time could pass differently on each side, potentially creating a time loop. But here's the catch. We'd need exotic matter with negative energy to make it work, and we've never found enough of that. So while the concept is thrilling, it remains purely speculative, trapped in the realm of theory. Imagine traveling back in time and accidentally preventing your grandfather from meeting your grandmother. Sounds wild, right? This is the essence of the grandfather paradox. If you erase your own existence, how could you even be there to change the past? It's a mind-bending contradiction that leaves scientists scratching their heads. Some argue that backward time travel might be impossible in our universe because these paradoxes create logical chaos. It raises questions about causality and the very fabric of reality. So, while time travel captivates our imagination, the paradoxes remind us that some doors might be better left unopened. Time travel in pop culture is a wild ride, isn't it? We see heroes zipping through time, changing history with a snap, or meeting their younger selves. It's thrilling. But here's the kicker. The science behind time travel is mind-boggling. Theories like wormholes and relativity suggest that time isn't just a straight line. It's more like a tangled web. Imagine trying to navigate that. Plus, every time you change something in the past, you risk creating paradoxes, like meeting your own grandfather. So while we love the drama and adventure, the real complexities of time travel remind us that some journeys are best left to the imagination.
Imagine stepping into a time machine and zipping back to the past. Sounds thrilling, right? But what if I told you that physicists believe time travel might come with strict rules to avoid paradoxes? They propose that any actions you take in the past would have to be self-consistent, meaning you could only do things that align with history as we know it. So, if you tried to prevent a major event, you might find yourself unable to do so. Your actions would somehow lead back to the same outcome. It's a fascinating concept that keeps our imaginations racing while reminding us that time travel, for now, is still just a theory. Time travel into the future isn't just a sci-fi fantasy, it's rooted in Einstein's theory of relativity. When we move at incredible speeds or find ourselves in strong gravitational fields, time actually slows down for us compared to those left behind. That's been confirmed through experiments with atomic clocks. But traveling back in time, that's still a puzzle. The laws of physics don't seem to allow it, and theories like wormholes remain speculative. As we dive deeper into quantum physics and the nature of gravity, who knows what we might discover? Time travel could be a reality, or it might just remain one of the universe's greatest mysteries.